In the photoelectric effect, you have a piece of metal, and we know there are electrons in there that when we shine light with enough frequency, those electrons will eject. And frequency is related to directly proportional to the energy of that wave, that light. So the incoming light has a certain amount of energy, and if that frequency or energy is greater than or equal to the threshold frequency or the threshold energy, then electrons will eject. If it's equal to it, it'll eject. Any excess energy that came in with that light is going to get transferred to kinetic energy of that electron. In other words, the higher the energy, as long as it's over the threshold energy, is going to transfer into faster or electrons with higher velocity or kinetic energy. So we can express what I just said in an equation. So we have the energy of the photon, that's the incoming light, is going to equal to the energy used to eject the electron, that's called the work function, or the threshold energy, and then any remaining energy from that incoming light gets transferred over to the kinetic energy of that electron. Now, this question is asking about kinetic energy, so let's rearrange this. So we can get the kinetic energy of an electron is going to equal to the energy brought in with the photon minus whatever went into dislodging that electron, the work function, or the threshold energy. So we're going to use this equation. All right, part A. The incoming light has an energy of 6.409 times 10 to the negative 19 joules. And it strikes the surface of a gold metal plate. And that gold has a work function, or a minimum energy to eject electrons, is 8.171 times 10 to the negative 19. So in part A, you can see that the energy of the photon is less than the work function, or the energy, the threshold energy. So for part A, nothing's going to happen. There is no kinetic energy because there are no electrons ejected. So there's your answer for part A. That incoming light doesn't have enough energy. Now part B, the incoming light has more energy. This time it's going to be more than enough because it's a 1 magnitude of 10 greater. So now we can use this formula. So let me just copy. All right, so there's the energy of the incoming light. So put that right there, energy of the photon. And then the threshold energy, also known as the work function, is for gold, is right there. So we're going to subtract and see what the difference is, and that's going to be the kinetic energy of the electron, or the maximum. All right, let's take our calculators out. 6.409 times 10 to the negative 18 minus 8.171 times 10 to the negative 19. All right, so there's the kinetic energy of the photons. And let's get 1, 2, 4 significant figures in this one. So 5.592 times 10 to the negative 18 joules.